Hello. All right. So evaluate cotangent 45 without a calculator. Without a calculator, how in the world would we do this? Well, let me teach you. Okay, so we want to do this with what I call the bow tie triangles. This is no way a mathematical term. It is something I made up for my students. So if you go to your friend and be like, hey, did you learn the bow tie method? Because I know you guys are always talking about math when you're hanging out, and they look at you like you're crazy, then that's probably why. Because you're talking about math, not because you're talking about the bow tie method. All right, so let's think about this. So I want to draw and draw a bow tie. So there's my XY quadrant, right? We're familiar with this. We're nothing new here. And I'm gonna just draw a bow tie in it. Okay. So one of the triangles that I'm gonna use when evaluating any trigonomic function is one of these triangles. This guy, this guy, this guy, this guy. They are all 90 degrees. Okay. My theta is gonna be here in the middle. So it's kind of like, I'm drawing it obnoxiously large just so you can see the theta symbol. That's like the knot of my bow tie, okay? So this angle right here would be theta. This angle right here would be theta. This angle would be theta. This angle would be theta. So on and so forth, okay? Now let's think about our AH's and O's, right? Adjacent, hypotenuse, and opposites. So we always are working with AH's and O's from our thetas. So A is always next door, right? So this one's going to be A. This one's going to be O. This one's going to be H. Okay, same thing with this one. Next door, this is my A. This is my O. This is my H. This theta, oh, A's already marked for me. That's great. O, H. A, O, H. Okay, and then think about positive and negative symbols. So think about just normal XY quadrant. If I go over to the right on the x-axis, this is a positive value. If I go up on the y-axis, this is a positive value. Hypotenuse will never be negative. Doesn't matter what this value is. Negative squared plus negative squared, those are both positives. And then if you were to do with Pythagorean theorem, you take the square root of the negatives, of the positive values, you're going to always get a positive. Okay, so let's think of this one. This is negative on the x-axis. If we go over from the origin, that's going to be a negative value. O, that's up. That's fine. That's positive. And then hypotenuse. So let me reiterate that. So let's say this guy right here. Let's say that's -1. So we have -1 squared. And then we'll say our opposite is a +1 squared. And I want to figure out what my hypotenuse is. So it's going to be hypotenuse squared. -1 squared is 1 plus 1 equals hypotenuse squared 2. We'll never get this number to be negative, ever. So our hypotenuse will never be negative, okay? Because we're squaring a negative number. All right, then this one, we still have a negative. Oh, I didn't do that part. Opposite would be positive because it's up. Hypotenuse is always positive. -a because it's negative x values. This would be going down on the y-axis, so this would be a negative. And hypotenuse is never negative, okay? So here's what we got. We got some positive A's, positive O's, positive H's. We go to negative, negative. Oh, we didn't do this guy. Positive A, negative O, always a positive. Okay, do you see that? If it was like a normal XY quadrant system, if I was down in this guy right here, this would be a positive X value and a negative Y value. This is a positive A, negative O. Okay, so just think about normal XY quadrant system, okay? All right, so to evaluate these trig functions, we're going to do the bow tie method. You also need to memorize, or you should already have memorized from geometry, your 30, 45, 30, 60, 90, and 45, 45, 90 triangles, right? So we should have those memorized. Hopefully we still do. If not, look at the notes online because it is right there for you, okay? All right. So we want to do cotangent of 45 degrees. So we're going to draw our XY grid. 45 degrees, that's up here. Remember, when you're drawing these, it doesn't really matter where you draw them as long as it's in the correct quadrant. Like you could draw it there, you could draw it down here. It doesn't matter, okay? It doesn't have to be precise. This is going to be 45 degrees. I need to do my reference triangle for a 45 degree triangle. So remember reference, 45, 1, 1. Hypotenuse is always the square root of 2, okay? So let's label that 1, 1 square root of 2. Remember, you still have like these little bow ties over here, right? It has to be one of these 4. If it was greater than 90, then we'd be talking about over here. If it was greater than 180, we'd be in here. If it was greater than 270, it'd be in here. So we are in quadrant 1. Okay, now let's label them as positive and negatives. This is positive x value, so we're good there. Positive y value, so we're good there. And then hypotenuse is always positive. So we don't need to change any of those values to negatives. Now, cotangent is the opposite of tangent, right? So tangent is O, so this would be an O. So let's go ahead and label these guys. That's A, that's O, that's H. So cotangent is the A over the O side. Cotangent of 45 degrees is the A over the O. So cotangent of 45 is 1. Look at that. We did that without a calculator. All right, let's try another one. All right, cosine of negative 135. So we got to figure out where negative 135 is. So negatives means we're going down. If I was going down here, that would be negative 90. That would be negative 180. So we're going to be here somewhere in this quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So we're going to be this direction. That's 135. What's left over in order to get to 180? 45 degrees. Okay. So we got 45 degrees again. So we need to think of our reference triangle of a 45-degree angle. 1, root 2. Okay. Is this one of my bow ties? Yep. It's never going to look like, if you guys draw your arc, it's never going to look like that. It's never coming off of the y-axis. That's why I'm saying the bow ties, because if you have your bow tie angles, the triangles all come off of this x-axis. None of them intersect with the y except for the theta values. Okay. All right. So then on this guy, so let's go ahead and label it. So we have our reference triangle. We know the a's and the o's are going to be 1. And the hypotenuse is going to be a square root of 2. Let's think about just a normal XY grid, okay? This side to the left of the origin on X is going to be a negative. Down is going to be negative. Hypotenuses are never negative. So we want to find the cosine of negative 135. You'll see that in parentheses a lot. It doesn't have to be in parentheses if you don't want it to be. It just doesn't make sense. It's not cos minus 135. Cosine is nothing without a degree or a radian with it. So this, with or without parentheses, it has to be a negative value of 135. That doesn't make sense for cos minus something. Cos is nothing without something with it. Okay, so cosine is A over H. So this, we said, was my adjacent, my opposite, my hypotenuse. So adjacent over my hypotenuse side. Okay, we can't have radicals in the denominator, so we need to rationalize that by multiplying square root 2, square root 2. Negative 1 times root 2 is negative root 2. Root 2 times root 2 is really root 4, which simplifies down to 2. We cannot cancel those out because one is in a square root and one is not. So cosine of negative 135 is negative root 2 over 2. This is how you guys can find them out by hand. You could memorize the unit circle and all of the values in it. I don't like memorizing stuff. I feel like knowing how to do it to where you can reproduce it if you were to have forgotten what you memorized. This is how you do it. So it wouldn't be a bad idea to memorize the unit circle if you're into memorization, but also know that you can always, always, always find the values, have you, forget that unit circle that you memorized once upon a time. Okay?